This is one of the problems that was due Thursday night, and we set these up in class. I want you to notice here to find f of negative 6. Since we are given the value of 7 at negative 2, then we say f of negative 2 plus the integral from negative 2 to negative 6. Now notice, if you integrate from negative 2 to negative 6, it's going to be the opposite of negative 6 to negative 2. That's how we get a final answer of 3. F of 5 will be f of negative 2 again, and then we're going to integrate from negative 2 to 5. Now notice, in order to find f of negative 6, we are going to integrate f prime. Okay, very important conceptually there. And then here you notice that you can leave pi in your answer. Again, that 2 pi is the area of a semicircle, which is pi r squared over 2. Now in part B, we're asked on what intervals is f increasing. So we're looking for f prime to be greater than 0, and that's on the interval from negative 6 to negative 2, and also from 2 to 5. It's where that f prime is above the x-axis. So it's increasing on those intervals. Okay. Now for part C, this goes back to the extreme value theorem, and or the use of it. We're saying that the absolute min will occur whenever the derivative is 0 or at an endpoint. Now we already have these values at the endpoints, so now we just look at the graph and we know that the derivative is 0 at negative 2 and 2. So now we can just compare those values. And the absolute minimum will be at f of 2, which is 7 minus 2 pi. Okay, 7 minus 2 pi. You can see that this is going to be less than this because the 7 is less than the 10. Okay. Now D is a little tricky here. If you look at the graph in the problem, f double prime, the second derivative of f at negative 5 is just the slope of the of f prime. So if you look at that slope is negative 1/2. But for the next part, when you find the second derivative at 3, it does not exist, because as you approach from the left and as you approach from the right, you do not get the same value. Okay? If you notice here, if you approach it from the left, you have a slope of 2. If you approach it from the right, you get a slope of negative 1. And that's why we are getting a sharp point there, that we have two different slopes.